Hello guys, so let's do lesson 2. We did the plates on the first lesson. Now we will do the structure. The structure will be similar to these plates. So we will Voronoi them so they can bend. The Voronoi between them, they will not break never. But then we have these joints between the elements. So here we have these 3 bars connected, or 4 bars, because there is another one there. These joints, they will be breakable. So I will take as reference point these plates. I can copy and paste this here. Let's turn off plates and let's select the structure, and I will delete all the elements there and select this structure. So we can go pretty fast. I don't want this Voronoi to be too small, so let's go to 15, I guess. Something like that will work. And yeah, we should be all set. Now in theory, if this works, yeah, we have these elements breaking. Because this is a structural element, I want to do 2 things. I want this to have more mass than the plates. This is very easy to change on physics shape. Let's go to mass. I will not use the relative, use the mass, and let's bring this to maybe 10. And the plates will be 1, so this will have 10 times more resistance. And on the physics shape, on the plates, I will do the same. I will keep it at 1. We don't have it right now, but then you will see it, that it makes a difference. Another thing is that this looks like it's not stiff enough. If we want more stiffness, you can see it here. It goes back to the original position very easily. On physics bind, remember, we have this stiffness value. So maybe it's these 2, let's go to 10. You will see that it should be way more stiff now. You can see it. It offers more resistance. Maybe let's go to 5. Yeah, now way more stiff. If you want, you can do as well that it takes more time to bend. So this, I am doing it on bind breaking. Instead of 4, maybe it's a 7 degrees. So after 7 degrees, it will deform, but if not. And I think that, yeah, these maybe behave better. Now again, as you can see here, when it breaks, we are not creating any bind here. I hope that you can see it. All the elements are apart. And before doing the binds, I can see something else, and is that these elements move. You can see that we don't have any interaction and they are moving. That's because they overlap a little. This is very easy to fix on physics shape. Let's go to ignore sharp penetrations. And you will see how right now anything is moving until the car hits. But again, I want to have some sort of connection here. When this piece moves, I want that this drags all these elements. To do that, copy this element, paste it, and that's a good moment to rename things. So this will be rename, this will be bind Voronoi, and this will be bind elements. And this will happen on when we create the cluster, remember, and let's visualize this actually. Show connections. It's not creating more elements, I guess, because the max bindings, because we are creating all these bindings here. And what I will do here is, that's weird that now automatically works, because I should see more bindings there. Bind elements. I don't exactly know why it should work right now, because it's doing what I want to do, but I don't have this enabled, and I should have these clusters match if it has different value. So now we are forcing that this will work only on these joints elements. That is what I was looking for. So yeah, that's great. So now when I move this, you should see this breaking, and I can see that we are not creating a joint here or a binding, and this can be because this distance. Let's increase this a little. Yeah, now we can see that it works better. But I want that this breaks, because if we make this not breakable, this will create a big mess. So next step will be to make this breakable. and I will do this with bind breaking. Let's see, bind breaking, we have the breakable on, but we need to say when this will break. Normally I activate max length. Let me bring this to 0. So this is when they are apart, 0.2, they break, by bend angle as well. I want this to break easily, so 15. Let's increase variation, and I like to use torque too, so based on a force. And now we should see that this, as you can see, it's moving a little, but it breaks quite easily. So that was what I was looking for. Something that can happen, let me see. Yeah, these elements are moving a lot below, and maybe I don't want that. I can send this to kinematic. Maybe it will not be visible from camera, but let's do it just to display more things. And I will use a physics switch. On physics switch we have this kinematic, and I will send this to this event based on surface test. And this surface test will be using, now it's calculating, this surface test will be using this element as selected. By distance, this is going there on kinematic. So these elements will not move at all. This will help the simulation. Maybe if you don't want that this doesn't move neither, we can have a helper there to fix this, but I think that will not be needed. So yeah, look, I think that this is pretty cool. Let's move some frames. And yeah, Tyflow is so fast. We are having some metal deforming. We don't have gravity so far. We will fix this next. Let me grab Tyflow. So I want that this, actually I want the exactly same thing. I want that this go there. Oops, sorry, not this. Let's go to the first frame. I want a property test. And before the surface test, and oops, and let's send, I cannot grab this. Now, let's send this to the same group. The surface test, remember that the timing is always to continuous by default. I like to send this to on-event entry. It will take less simulation time, and I only want this to happen on the first frame. So that's great. Now we have this force going on, and now we will have one problem later on, and will be that this, we are sending the, sorry, I didn't rename this, here we have the structure. The structure and the plates will go to this event, but we want to differentiate this later, and now all the particles are going there. Normally I do this with a group, particle group, structure will be group A, don't change simulation group, and plates will be group B. That will be important later, but it's a way that here we can differentiate things. Great, now it's time to activate the plates, because we will see something, I guess, and I want to showcase you this stuff. And yeah, let's bring the plates. This will take maybe some frames, some more seconds. And yeah, actually, let me try to go to a frame that I can see it. And yeah, I wanted to showcase you this. I am creating now bindings between the plates and these structural elements that maybe I don't intend to do, maybe you want, but right now I don't want to do that. Because when I'm creating these bind elements here, it's creating elements between the structure and the plates. And this, what will make, well, it make that it's breakable. That's maybe good. I would like to know as well why this is breaking by default when I have this set to property test. Oh, I think I was tweaking some things before. So let's bring this to 0.5 and let's bring this property test to 0.5. This should be at 0.5 if you come from the previous lesson. So now, maybe you want it to be like that, but I I am creating bindings between the plate and these structural elements here. And this is happening because I am having this based by clustering, because this has a different birth ID than this another birth ID. It's not something I want. I only want to create bindings between the plates here, between the structure here. So to do so, there are different ways. I talked with Tyson, and we will have later on a way to do it easier. But something easy when you only have two events is to make use of this evaluation priority. I will evaluate first the structure, and now plates are evaluating exactly at the same time. So internally it's using first one and then another second. But if I make that these plates are evaluated second, you will see that these bindings will disappear, in theory. Let's see. Yeah, you see, they disappear. So now we don't have bindings between the plate and the structure. And this is happening because first it's evaluating the structure and it's creating these binds, but these plates doesn't exist yet. And then we are creating the plates. Another way to do it will be with the simulation groups. I can put these simulation groups to 1 and 2. These simulation groups will be at 1. And then I will use on binding elements. You can use these simulation groups to when it's 1 and 2 equal. So then it will happen only with this. I hope that this is not too confusing. You can use right now this the technique that I use here to evaluate this second. And later on we will have a way to evaluate only the elements here. And I am doing that because maybe I want to have these bindings between these two elements, but here. So then I have more control because you can control the binds of the plate alone, you can control the binds of the structure alone, and then I will be able to control the bindings between plates and a structure alone. So to do that, I will do birth. Sorry, not birth, but physical bind. And let's not display these ones because I want to see what we are creating here. And yeah, let's go to rigid joints maybe. And actually I don't want this to happen this way. I am making this go to property test by velocity. But what I want is to send a group these two together. So I will do a send out. Now I have some problems. Send out. And this will be as well sent out. So all elements will go there. What's happening today? Send out. And then from here, I will do the surface, the property test. So then I don't need a property test there. I hope it makes sense. So now all the particles are on this group even before they are activated. So in this group we can do things between these two groups. And I will create here this physical binding. And on this physical binding, I want to make this binding happen when these are two different groups. So we define here A and B. So I want to use these clusters happening based on these different two groups. But we don't have a way to define this. We need to first have a particle property. So on the newer Tyflow, we have something. Let's call create custom properties. These custom properties needs to be after the groups, and then we can say here we have export groups, not simulation groups. Use as export groups, and let's create a new channel. This will be groups. What this is doing is that if a group is A, it will save on groups 0. If it's B, 2. If it's B, 1. If it's C, 2. If it's D, so every group will have a different number. We can copy this with shift and drag on the plates. You don't need to tweak anything else because automatically, sorry, not particle groups, the custom properties after the groups there. and yeah, automatically will create a different number. So now on physics join on clusters, let's move on clusters and let's select these groups that we created. And I will do cluster if match has different value. And now doing so, if everything is good, show connections, we should see something there, and maybe looks wrong, but that's only because we have this bind distance is too big. So if I put 1 or 0.5, we can see that it's creating only bindings between plates and a structure. And that's perfect because now we have control. Remember, we want control when we work on shots, and now we can control whatever we want. So now we can control independently what happens between plates and a structure. And I will make this break rather easily as well. And then remember, yeah, I will switch this to the join is good and that values are good. And with this, I think that we will finish this second episode, and I hope that you like it. We discovered different things, creating joins or bindings, and how to make it really R directable. At the end, what I want is to make all these R directable. So if from your lead or the supervisor wants the binding stronger only between plates and structure, now you can do it because we have it totally separated. Yeah, I think it looks pretty good. We have these breaking elements there. It looks really like metal. And yeah, maybe you want to have more action on different areas, but I think that maybe this looks pretty good. If you want to have, for example, these elements more active now that everything is working. So one thing that you want to do is to make the resistance between elements stronger. So we will make that it breaks less easy. We will increase maybe the torque and maybe this max length and the bend angle, and you will see that this should affect more other areas. You see, only affecting the torque, you can see that it affects way more this area there and affects more these areas. Now again, maybe the plates break a little too easy. If the plates break a little too easy from the structure, another way to do it is from here. So it's only to demonstrate that we have absolute control now in how all these behave. And yeah, it's what you would like in production, to be able to know the bindings here means plates between a structure, the binds here mean the joints between elements, and so on and so forth. And yeah, as you can see now, these elements are more affected. That is maybe what I was looking for. So great, on the last episode that will come later on, we will see finally how to bring high-res mesh here and how to add some extra details on these elements. And yeah, I hope that you like so far this tutorial. I think that there is cool information. And thank you guys, see you soon, bye.